Hello guys, welcome to you all. So today I'll show you how we can easily calculate RMS and mean values of either voltage or current. So before directly jumping into the topic, I just want to give you a little information about the signals, about the sinusoidal signals, which look something like this. Also the non-sinusoidal signals, which might look completely random. I'm just giving an example here. So on the basis of these two signals, we are going to discuss few parameters. There are three parameters which are important to know before calculating the RMS and mean values, so you exactly know what we are talking about while finding those values. So first parameter I'm going to talk about is period. So period is simply the time taken by a cycle to complete. So in case of sinusoidal signal, this is mostly equals to pi, and in case of a non-sinusoidal signal, it depends on the signal. If the signal looks something like this, which repeats over the time, then it's simply pi or something. But if it is unique over the entire measured time period, then it could be the entire time period mentioned. Period is equals to time period. So mostly the period is represented by capital T, and second parameter is frequency, which is represented by F. So frequency is simply 1 over period. And third one is an amplitude of the signal. Amplitude is mostly for the sinusoidal signals. It is just the magnitude of the signals, you could say, which is mostly used in representing a sine wave. For example, if this is a voltage signal in time domain, then this voltage signal is given by the expression of amplitude times sine of omega t. Omega t is the domain in which the signal is traveling, and in this case there is no phase. If there exists a phase, this expression becomes u cap sine omega t plus phi u, where phi u is the phase of the voltage signal. So these are some basic parameters you should know before we jump into calculating RMS and mean values. And now I have this voltage time signal, for example. So and I'll help you, or I'll teach you how we can easily find those values. First one is average or mean value, in this case of voltage, and the RMS voltage. Mean value can be done or calculated in two ways, that is by using the same formula, which is 1 over t from 0 to t and u of t dt. If you want to calculate u of t or voltage, it's e of t, and if it's current, then it's I of t dt. First thing, we could either do it with integration, that is 1 by t, integral of, for example, every change in current with respect to time. For example, the voltage is stable until 2 seconds if you are considering time, so it goes from 0 to 2. Voltage here is 2 dt, and then repeating the same for every change in current, every change in voltage with respect to time. So from 2 to 5 there's a change, and the change, you have to determine the slope here. For example, the points here are 2 comma 2, and here it is 5 comma 8. So 8 minus 2 by 5 minus 2, gives you 6 by 3. Slope we get slope equals to 2, and you put that slope in this equation 2x plus c, and substitute any of these coordinates in this equation. For example, we take 2 comma 2 here, so y equals to 2, 2, and x equals to 2 plus c, which gives you the c value, which is equals to minus 2 in this case. So finally what we get is u of t, which is basically y in this axis. Voltage is equals to slope is 2 times t minus 2. This is the expression for this line over here. So simply put 2 t minus 2 dt. This should be done for every change in time voltage, and finally adding those values and dividing it by the frequency, which is 1 by t. This is one way to do, which I think is a little bit hard to calculate, and there is also a simpler way, that is just simply dividing the areas of the signal in squares, in rectangles and triangles. For example, if you observe the area under this curve, or the area covered by the signal, you could easily make it into rectangles in this way. Any area could be made into squares, into rectangles and triangles. So here is area 2, 1, 3, 4, 5, 6 and 7. Total there are 7 areas, and simply we could calculate the average value by performing certain steps, following steps. That is, area for the first rectangle is 2 comma 2 by 2, 2 multiplied 2, and adding it to the second area, which is area of the second rectangle, that is 3 by 2, because 3 in x and y in 2. And for the triangle, it's 1 by 2 times base times height, which is base is 3 here and height is 8 minus 2, which gives you 6. And they should be done for every area, and finally get the total area and divide it by the frequency, which is 1 by t. So this is the simple way to calculate the mean value. But when it comes to the RMS value, only integration method is accurate, with my experience, I can say. So for calculating RMS value, the formula is also similar, that is 1 by t integral 0 to t, but in case of voltage or in case of current, it should be squared every time. So for example, 1 by t for this area we are going to calculate now. Integral of 0 to 2, because we are going to find the RMS here, 0 to 2. The voltage here is 2, so if it is stable, then you could directly enter the value, but when it is when the voltage has an inclination or declination, then you have to calculate the line equation, similar to what we did a few seconds ago or a few minutes ago. So 2 to 4, what this line was 2t minus 2, so simply 2t minus 2 whole square dt, and perform the same calculation we did before to get the line equation, and add the line part here, this line Also, this is directly the value here, which is -4 whole square. Don't forget to square it every time, and you'll get the RMS value. Let me know what are the average or mean values for this signal in the comments, and post your questions if you have any in the comments too. Well, then, thanks for watching. Hope you could easily solve these problems in your exams. Thank you.